This is a solution video for Chemistry Paper 1, Set 6. You can download a soft copy from the description below, or you can skip to the end of the video for the answers. Question 1. Which operators can be used to determine the endpoint of a titration involving acid, HCl, and 25 cm³ of sodium hydroxide? Okay, so you're trying to determine the endpoint. Okay, so if you want to determine the endpoint, so this is a neutralization. Okay, so you do not need an electronic balance because there's no mass to measure. Okay, so you are trying to measure the endpoint, the volume. Okay, so stopwatch, no, there's no gas produced as well, so you do not need a gas range. Why you need a thermometer is because neutralization, right, it will be an exothermic. So if you draw your temperature graph, okay, so the temperature will increase until the highest point, then it will start dropping down. So at this point, it will be the end point, okay, whereby it give you the maximum temperature, okay, increase. So answer will be D. Okay, next one. Question 2. Which of the following procedure best explain, okay, best method to obtain a pure sample of barium chloride from a mixture of barium chloride and barium sulfate? So first thing first, from your salts, okay, solubility, you know that this will be insoluble. This will be soluble. All right, so if it's so you're trying to obtain barium chloride, okay, barium chloride. So you need to add water and remove the insoluble barium sulfate first. So you add water, okay, this solution means adding water, and then you do filtration to remove okay, to remove barium sulfate. Okay, then you do saturation, heat to saturation, then you do crystallization. Okay, so answer will be B. Moving on, question 3. 100 cm³ of CO2 gas diffuse through a porous spot in 50 seconds. Okay, so this one should be under diffusion, rate of diffusion. 100 cm³ of X, same volume, okay, but it will take more than 50 seconds. Okay, so if you look at CO2, if you take a look at CO2, the MR is actually 44. So if gas X takes more than 50 seconds, so MR of X will definitely be greater than 44. Okay, so we just need to get the MR of everyone. This NH3, H2, CH4, and SO2. So if you look at our periodic table, this will be 17, 2, this will be 16. This one, you add up everything, will be 64. Okay, so the only answer that makes sense will be D. Question 4. Which statement explain why NaCl has a lower melting point than magnesium oxide? Okay, so this is under chemical bonding. So this magnesium oxide. Okay, so one look, you know that both of them are ionic. Okay, but the thing is that for NaCl, right, the charge for the ions is Na plus and Cl minus. But for magnesium oxide, although he's also ionic, the charge will be higher. Okay, so the higher the charge, the stronger the electrostatic force of attraction. So the answer will be, so the bonding will be stronger. So answer, this one, reactive is not. Attraction is weaker, seems correct. Boiling point is lower, no. The boiling point thing is covalent, no, that is not true at all. Okay, so answer will be B. Alright, so use the charge. Question 5. So following shows a molecule made out of 3 different elements. Okay, so it's a molecule, so most likely they are all non-metals. Okay, So Y form 1 bonds only, so Y the charge will be 1 minus, and then X form 2 bonds, okay, so the charge will be 2 minus. Okay, let's look at the option. So it can't be a metal, and it must be minus, so oxygen is out, hydrogen is out, so answer will be B. Okay, Cl is minus, oxygen is 2 minus. Okay, although sulfur is possible as well. Okay, next. Why does magnesium oxide has a higher melting point than sodium chloride? Okay, so this is very similar to the previous question. So the bonding is stronger. Okay, it has a stronger bonding, although both are ionic. Okay, so the electrostatic force of attraction between magnesium and oxide ions are stronger than that. Yes, that's the answer. The rest does not make sense. Yeah, it's not intermolecular force of attraction because it's ionic. Okay, both of them are ionic compound. So answer will be C. Question 7. What element could X and Y be? Okay, so this is similar again. So Y form 1 bond, and then X is 3 bonds. Okay, so X 3, okay, group 15, and then this is just a minus, so answer will be B. Moving on, question 8. Which one is true for diamond and graphite? So this is under chemical bonding. So both of them conduct electricity, no? Only graphite can conduct. Both have same color, not true at all. Both of them have same crystalline form, not true. Only diamond is a crystalline form. So both produce CO2 and water vapor when completely burned in air. Yes, that is true. So answer will be D. Okay. Empirical formula. So you have carbon. So let's write the element first. Carbon, hydrogen, oxygen. Okay. So next you will write the percentage mass. So which is 52, 13, 35. And then your AR 12, 1, 16. Then it's mole. So it's mass. So it's 52 divided by 12. So you get 4.33 is 13. 35 divided by 16, you get 2.19. Okay, then you go for the simplest ratio, so everyone divide by 2.19, so it is 13 divided by 2.19, so you get closest is 6. Okay, so you need 2 carbon, 6 hydrogen, and 1 oxygen. So let's look at it. The answer will be C. Okay. Moving on. Question 10. 4 dm cube of ethane. So this is I can write here 4 dm cube, and 16 cm cube of oxygen gas. After the reaction, it was cooled to room temperature. Okay. So what's the final volume? So this one, take note, this one is under your mole, and then specifically is the limiting reactant. Okay, because there will be excess of one of your reactants. Let me show you the working here. So C2H6 dot dot O2. So it's 2 is to 7. So if 2 units is 4 dm cube, 7 unit will be 14 dm cube. Okay, so in other words, you have excess 2 dm cube of oxygen gas. Okay, so a shortcut is here you write before, then below you just write after. Okay, so push up it. C2H6 is your limiting reactant. So all of your C2H6 will be used up. So this is 0. So this is your limiting reactant. So this one, you need 14, but you add in 16, so you have 2 dm cube extra. This one at the start is 0, 0. And then, so you do your mole ratio between C2H6, because that is limiting reactant, to your CO2. Okay, it's 2:4. So in this case, you can do volume ratio, because they are all gases. Okay, if not, you have to do mole ratio. Okay, so take note, volume ratio here. Okay, so this is 4. This one should be 8 dm cube. Okay, so this 8 dm cube. Okay, final volume of gases. So this one, water, right, will become water will become water. Okay, or your H2O will become water. So it does not exist in a gaseous state. So we won't even calculate that. So answer will just be 2 plus 8. Will give you 10 dm cube. Okay, so you have 8 dm cube of CO2 and the excess 2 dm cube of oxygen gas. So answer is B. Okay, so this one is a very common question. Make sure you know this. Moving on, question 11. Okay, so this is similar again. Let's try this again. So this is 200 cm cube. This 200 cm cube. Okay, so SO2 dot O2, 2 is to 1. So if this 200 cm cube, this should be 100 cm cube. Okay, so you have excess 1 cm cube of oxygen gas. SO2 is the limiting reactant. Okay, so this is your limiting reactant. So at the start, this is 0. So everything is used up, SO2. And then oxygen gas, you only use 100 cm cube. So you still have 100 cm cube excess. Okay, and then let's do the mole ratio. SO2 to SO3, 2 is to 2. So if this 200 cm cube, this will be 200 oops. Okay, so it's 200 cm cube. So if they want the volume of the final gas remaining, so the working will just be 100 plus 200. Okay, so answer will be C. Okay, just put here. Moving on. Question 14, an aqueous solution has a pH of 14, so this will be your alkaline. So what does it imply of the ions? Okay, so this is a good question. So your OH minus definitely will be high. Okay, but that doesn't mean there's no OH, there's no H plus. Okay, there's still some. Okay, it's just that it's very little. So answer will be A. Okay, so take note, there will still be some H plus. It's just that it's very little. Question 13. Which of the following suggests that the underlying oxide has amphoteric properties? So amphoteric oxides, they are metal oxides. Okay, or metallic oxides. Okay, so they can react with both acid and bases. Okay, but the thing is that it is basic oxides, which are also metallic oxides. They can react with what? Because they're basic, so they react with acids. Okay. Okay, react with acids. So, but the unique thing is what? Between basic oxides and amphoteric oxides is this part. Only amphoteric oxides can react with bases. So now your job is to look for the reaction whereby it can react with bases. So this react with water is no, react with acid no. This one react with base possible. Let's look at option. And then it must be a metallic oxides. Okay, so Cl is not a metal, so it's out. So answer will be A. Okay, by elimination. So look at all the clues. Question 14. Which of the following salts can be prepared using the same methods? Okay, so this preparation of salts. So so you have the first method, which is the acid with excess insoluble solid, or also called the filtration method. Second will be your titration. And third will be your precipitation. Alright, so calcium sulfate is insoluble, so it's precipitation, so it's the third method. Zinc chloride is soluble, but it's not spar salt, so it's the first method. Copper 2 sulfate is first method. Silver nitrate is soluble, but it's not spar, so it's the first method as well. Potassium is a spar salt, so it's the second method. Magnesium nitrate is soluble, but it's not spar, so it's the first method. Potassium iodide, potassium salts are all soluble, so it's the spar, so it's number 2. Silver iodide is insoluble, it's precipitate. Alright, so answer will be B. Okay. Question 15. So this is the Haber process. Under ammonia. So the optimum condition is 450 degrees Celsius and 250 atmosphere. Okay. So which of the following graph shows a correct comparison to the yield of ammonia at 500 degrees Celsius and 250 atmosphere? Okay. So when temperature is higher, if you memorize the chart, the graph, the yield should decrease. Alright, so it should end at a lower point. But at the same time, under rate of reaction, temperature higher, your rate of reaction will be higher. So the gradient will be steeper. So the gradient is steeper. Okay, but the yield will be lower. Okay, so B looks good. Okay, so a steeper gradient, so it's correct. And then this is steeper gradient as well, is correct. This is definitely out. And then this steeper gradient is correct. But the yield must be lower, okay? Lower yield. So lower yield is good, higher yield is no good. Yeah, so answer will be B, okay, by elimination. So I repeat again. So you need a lower yield, okay, and then higher gradient, means you need a steeper gradient. So answer is B. Moving on, question 16. Which oxide is insoluble, okay, in aqueous sodium hydroxide? So this is under your oxides family. So insoluble means does not react, does not react with alkaline, okay. So you're looking for basic oxides, which are metallic oxides. Okay, so you cannot choose amphoteric. Okay, so aluminium is a metal but it's amphoteric, so it's wrong. So this is a basic oxide, this is acidic. Okay, so answer will be B. Next one, question 17. Which row of information correctly display the reactants used to safely produce a salt with the highest possible yield? So this is under salts. Okay, so to form calcium sulfate is method 3 is insoluble salts. Okay, so it's precipitation. This is first method. Okay, lithium is a group 1 is spar salt, so it's method 2 titration. Okay, then zinc sulfate is just a normal soluble salt, so it's the first method. Okay, your excess acid or the filtration method. Okay, I mean excess solid, not excess acid. This is precipitation, and this is your filtration. Okay, so filtration, to form copper 2 chloride, copper cannot be used because it's unreactive. Okay, so B is out definitely. Titration, you need acid and alkaline. Okay, so you cannot use the metal itself, it's too reactive, so it's out. Filtration, precipitation, you need your reactants, you need aqueous plus aqueous. Okay, both 2 soluble salts. And calcium oxide is solid. Okay, so it's out. So the only one that makes sense is D. Okay, by elimination. Next one, Question 18. This one should be under your QA. So adding sodium hydroxide, this to test for your cations, okay? Test for cations. Why PPT soluble in excess to give you a colorless solution? So you have your possible candidates are your zinc, Pb2+, and aluminum 3+. If you add aqueous ammonia, this to test for your cations as well. You have what PPT soluble in excess. This is only zinc, colorless, okay? So it must be zinc. And then barium nitrate, this is to test for your sulfate ions. If you look at our QA table, so this white PPT is actually you have a white PPT format in this one. Okay, be careful this one. Although it's barium nitrate, but you realize the order is different now. So you form barium nitrate and you have white PPT, okay? And then when you add acid, right, the white PPT is soluble. So this is actually means what? It's a carbonate. Because this PPT is barium carbonate, okay? Then the barium carbonate will react with your nitric acid to form a soluble salt like barium nitrate, okay? Okay. Yep, just balance the first one. Yep, should be okay. Okay, so means there's carbonate in the solution. Okay, so be careful. Don't jump to sulfate as a conclusion. Also have to read carefully. So the only one that makes sense is it must be zinc, and carbonate. So zinc and carbonate. So answer is D. Okay. Next one. In Haber process, the high yield of ammonia is favored by high pressure and low temperature. Okay. But in practice, a high temperature is used because what? It will be faster. Okay. Although your yield is good, but higher temperature, the rate will be faster. So at low temperature, the reaction is too slow. Okay. Yes, this one. Okay. So answer is D. Question 20. Which of the following is not a redox reaction? Okay, so you have to use a oxidation number. That's the best. So let's say this is 0 element and magnesium is +2. So this is definitely a redox. And then nitrogen here is -2. Here oxygen, I mean, is 0. So this is actually a redox as well. And oxygen is -2, so sulfur is +4. Here's -2, but sulfur here is +6, so there's an oxidation, so this is a redox as well. And oxygen is -2, sulfur is +6, hydrogen is +1, oxygen is -2, oxygen is -2, hydrogen +1, sulfur is +6. So this one, yeah, none of the element oxidize or reduce, so this is not redox. Okay, so answer is D. Moving on, 21. You're using sodium hydroxide to identify the ions, so this is under QA. So let's look at this. For Q and R, before addition of sodium hydroxide, so you have Q. Then after you add sodium hydroxide, is green PPT. So this definitely will be iron hydroxide. So you add sodium hydroxide. A gas is given off, so this gas most likely is ammonia gas. Okay, so this is testing for cations. This is also testing for cations. So you will have your NH4 plus is here, and then this is your iron 2 plus. Okay, so answer will be this one, and this answer is A. Moving on, question 22. Which one is the test for redox reagent? So if you want to test for oxidizing agent, you need a reducing agent, which is your potassium iodide. Okay, you will turn from colorless to brown. Alright, so answer will be D. Okay, so this under redox. 23. So this is under electrolysis. aqueous. Copper to sulfate is using copper electrode. Okay, so watch out, it's copper electrode. So if you draw a fast setup, so this plus, this minus. So this plus, all the negative ions will be coming here. SO4 2 minus. I just write it at the side here. SO4 2 minus and OH minus. Okay. And then this one will be CO2 plus and H plus. So this will be the anode. Okay, anode will undergo oxidation. This will be our cathode, will undergo reduction. And take note, because you are using copper electrode, okay, so here copper will be one of the possible candidates to be oxidized. Okay, so this will never oxidize, and usually it should be oxygen gas, okay, to produce oxygen gas, but in this case copper is actually lower, so copper will be oxidized to give you copper 2 plus. Alright, so this one, whenever it's a copper electrode or when it's a reactive electrode, so you have to watch out. So what actually happened at the anode? So yep, so answer should be A. Okay. 24. 4 cell to produce electricity. Okay, so this answer simple cell. So which one give you a largest voltage? So the two metals must be further away. Okay, further away. Okay, the two metals in the reactive series. So let's look at the option. So if you do your reactive series, the ranking, magnesium will be the highest among here, followed by zinc, then copper. Okay, so if you want the brightest, sodium is here, so sodium is possible as well. So so sodium and copper will be the best because you want the largest voltage. Okay, but the keyword is what? You want it to be a safe way. Sodium is too reactive. Okay, you react with the water to produce your hydrogen gas. Okay, so sodium is out. So the next best choice is magnesium. So I think I will choose D. Alright. Okay, the electrolyte, the solution does not matter as long as it can conduct electricity. 25, moving on. This under periodic table. Which one could not be predicted using the periodic table from the position? So the only one that makes sense is D. Okay, the isotopes can't be determined using the position in the periodic table. So answer is D. Okay, this is under metals. So reaction of substance X. So X can react with water. So X plus H2O give you XO plus hydrogen gas. Okay, so this shows that X is above hydrogen. Okay, so X is above hydrogen. Yep, so answer should be A. Okay, so it can't be an oxide because you produce hydrogen gas, so it can't be an oxide of X. 27 shows a special property, a specific property. Okay, so what's the property whereby a neon will be 0? Okay, so we do not know what is this property, but the property for neon will be 0, will be, can't be this one, can't be this, should be this one. Okay, number of electrons used in bonding, because neon is already group 18, is have a full outermost shell, so it does not undergo any bonding at all. So answer will be C. 28. The element in a group should follow the trend. Element with the lowest proton number has the lowest reactivity. So actually means what? Reactivity decreases down the group. So it sounds like group 17. Okay, when decreases down the group, oh no, might not be group 17. Okay, so melting point decreases down the group. Moving on, density increases down the group. Okay, let's see. It can't be group 17. Okay, group 1, element with the lowest proton number has the lowest reactivity. Yeah, sounds like group 1, correct? Group 1, your melting and boiling point decreases down the group. Okay, but reactivity will actually increase. Reactivity increases down the group. So they say the element with the lowest proton number has the lowest reactivity. That is true. Lithium has the lowest reactivity, and then melting boiling point decreases down the group. Density will increase down the group. Yes, so this is referring to group 1. So answer is A. Okay, your alkali metals. (29) The following observation is shown when nickel and iron is added into S, T, and U salt solution. Alright, so from here you can tell they are looking for the reactive series, the metal ranking. So let's see, nickel, when added into salt solution of S, solid deposit is formed. So S is being displaced out. So nickel will be above S. Okay, and then T and U will be above because they can't be displaced by nickel. Okay, then next, nickel can displace S and T but not U. So U is definitely most reactive. Okay. Okay, and I need to add in iron. Iron will displace S and T, so iron will be somewhere in between here. Okay, so in the decreasing reactivity here, so you start from the best, so it's U, then F, E, T, and yes, that's the one. So answer is C. Moving on, question 30. A carriage is being restored by having metal strips secured to the outside. Okay, so after a few weeks exposed to wind and rain, the screws are heavily corroded. Okay, but the metal strips are not. Okay, so only the screws are being corroded, so only this part. Okay, so another, this means what? This means the screw, the metal screw is actually more reactive than the metal strips. Okay, so the screw must be a more reactive metal, and this one must be a less reactive. So answer should be C. Okay, so the more reactive metal will corrode. So this is made of iron, whereas your strips is made of copper, so it's less reactive. Question 31. So you have 3 metal carbonates, okay, heated. So on mild heating of white carbonate, a white precipitate is observed. So yeah, okay, so there's CO2 gas produced, of course. Heating more strongly give the same observation for XCO3 but not ZCO3. Okay, so this means a Z carbonate will not decompose. So Z definitely is the most reactive. Okay, heating more strongly give the same observation for X. So X is second. Y is the weakest metal. Okay, because it just by mild heating, it will already give you your CO2. So this is the weakest. Z is the most reactive. Most reactive. So the ranking will be, yeah, this one, D. Okay. 32. This is your introduction to organic chem. So which statement about the fractional distillation is true? Okay, at each layer only one compound. No, that's not true. It's actually a mixture. Okay, so wrong. The higher the column, the greater the temperature. That is wrong. It's lower the temperature. The molecules collected at the bottoms are the most flammable. No, they are the least flammable because they have the highest boiling point. So it's wrong. The molecule reaches the top of the column has the smallest MR. That is true. Okay, that is true. So answer is D. 33. Pentanoic acid. Okay, so there's 5 carbon. 1, 2, 3, 4, 5. Okay, so which one represent butyl pentanoate? Butyl is 4 carbon, then pentanoate is 5 carbon. Okay, so you want to draw butanol first. Okay, butanol. So it's 1, 2, 3, 4 hydrogen. Okay, the remaining are hydrogen. This is butanol. Okay, then this one is the pentanoic acid. So if you want to draw it out, 1 carbon, 2, 3, 4, 5. Alright. So these two will actually react. So answer will be this is 1, 2, 3, 4, 5, 6. Okay, so this out. You need 5 carbon. Let's try this one. I think this is good, right? 1, 2, 3, 4. This come from the alcohol group, means the butanol. And then here is 1, 2, 3, 4, 5. This come from the pentanoic acid. Okay, so yep, answer should be C. The rest does not make sense. This out, this out. 34. What are the reaction PQRS? So let's see this one. From here to here is obviously will be your cracking, and from here is hydration of your alkene. So from here C2H5OH is ethanol. This is ethanoic acid. So process R will be oxidation from alcohol to carboxylic acid, and from ethanol to this is your glucose. Okay, so it's the reverse, so it's actually your fermentation. Answer will be hydration is a kind of addition reaction, and then this is your cracking, of course, so answer will be A. 35. The diagram shows the structural formula of tartaric acid. Okay, so you can see it has the COOH group and also the OH group, the hydroxy group. So what salts can be formed by reacting tartaric acid with sodium hydroxide? So let's see, when you react with sodium hydroxide, so this is the part that they will react with. Okay, so the Na plus will go in to remove the H, then it replaced by Na plus. Okay, so answer will be, let's see, so you'll get C4H6, still same thing, but O6 Na2. Okay, this one you have to change 2 hydrogen lesser, so left with 4. Okay, so answer is 2 is possible. Okay, they can actually just react with one of the sodium, one of the hydrogen to form your COONA. Okay, so this can remain as hydrogen also, so it's just C4H5O6. Oxygen remains the same, but Na. So you can react with just one sodium or react to give you 2 sodium. Okay, so this is actually possible as well. So answer is B. Both are possible. Okay, moving on, 36. So 0.25 mole of vegetable oil is found to increase the mass by 25.4 grams when react with iodine. Okay, so first we need to find the mole of the iodine. Okay, so mole of iodine, mass over mR, 25.4 divided by 25,254, you get 0.1 mole. So now you do your mole ratio from the vegetable oil to iodine, which is 0.025, 0.1. Okay, so if you do the mole ratio, you will get 1:4. Okay, Then, so take note. Let's say if you have one CC double bond, when you react with your iodine, you kind of open up the double bond, and then you can plug in your iodine. Okay, so means one CC double bond represent one iodine molecule. So since you have 4 here, 4 iodine molecules means it has what? 4 CC double bond. Okay, so answer will be D. Next one. 37. Ethanol can be manufactured from ethene or glucose. So by ethene, from ethene will be hydration. From glucose will be fermentation. Okay, so which of the following rows are correct? So let's look at by glucose fermentation. Oxygen is produced in the reaction. No, it's not oxygen, it's CO2. Okay, so it's wrong. The rate of reaction is slow. Yes, fermentation is pretty slow. Temperature is around 100. No, it should be about 37 degrees Celsius. And then reaction carried out reagent is as gases. No, glucose and yeast. Okay, glucose is solution and yeast is just a solid, so it's wrong. So by elimination, it will be just B. Okay. Question 38. So you have this full structure formula. Which one is incorrect about this acid? Okay. So let's take a look. So it has a COOH. Okay. You have a hydroxy group, alcohol, and then a CC double bond. Okay. So this one is a carboxylic acid. This is under alkene. Then this is under alcohol. Okay, so a diol is formed when it reacts with steam in the presence of phosphoric 5 acid. So it's under hydration. So meaning your CC double bond will become a C and C, and there will be OH. So now you have 2 alcohol. Okay, you have 2 alcohol. Seems okay. A pungent gas evolved when sodium react with this solution. No, you'll form hydrogen gas. So it's not pungent. Hydrogen gas is not pungent. You can form from addition and condensation polymer. Let me see. It can form from both addition and condensation polymer. Addition. That sounds wrong. Okay, let's put the question mark first. It's not a hydrocarbon. Yeah, definitely this is true. Okay, because it has oxygen as well. So which of the following is incorrect? Okay, so it's either B or C. Let's see again. Let's look at the option again. Pungent gas is when you add sodium. Okay, let's use blue. Okay, so the sodium will just react with this, and you'll form hydrogen gas. Hydrogen gas is not pungent. Okay. Option C, it can form both addition and condensation. Oh yes, okay, yeah. I thought it's formed from. Okay, it can be used. Okay, because it has the CC double bond, so it can undergo addition. Okay, and then it also have your either OH or COOH group, so it can undergo addition, condensation, polymerization as well. So this is correct as well. So answer will be just B. Okay, B is the one that is false. 39. In which reaction does the product have more carbon atoms than the reactants? Okay, so the number of carbon atoms actually increase after the reaction. Okay, so let's take a look. Oxygen and pentane. Pentane has 5 carbon. CO2 only have 1 carbon, so unlikely. Carboxylic acid and amine become amide. Possible. This possible. Alcohol oxidized. The number of carbon should remain the same. So it's no. Carboxylic acid react with salt. The number of carbon should remain the same as well. Okay. So answer is A, yes. Okay, by elimination. Question 40, okay, the ester linkage. This is the ester linkage, and this is the ester linkage. Okay, so below can first be hydrolysis to obtain its monomer by heating with dilute acid. Okay, so by heating with dilute acid. So when you add acid, what actually happen is this ester linkage will be broken. Okay. So then you add sodium hydroxide is added to the monomer form. Okay, so after that you add sodium hydroxide. So there's two reactions going on. So what will be the products now? Okay, so let's try one by one. So when you add the acid, okay, so you'll form back H. Okay, this is the first one. Then the middle portion, you'll form back this. Okay, those are the carbon, so I'm not going to draw the carbon. Okay, so meaning important is you add back the H here, add back the OH, add back the OH, and here you will add back the H. Okay, and then of course the last product will be HO. Okay, then C double bond O, CH. Okay, so these are the three products. The first one, second one, and the third one. After that, you're going to add sodium hydroxide. Okay, so when you add in sodium hydroxide, what's going to change is this hydrogen will be replaced with a Na. Okay, and then this will not react. This will replace by Na because it's an acid. All right, so okay, if you want the plus, that's the final answer. So let's look at the possible option. This is wrong, definitely. This looks good. This looks good. Okay, so second one, it should be OH. Okay, so this is good, this is good, this is wrong, and yep, so answer will be C. That's all. Like, share, subscribe.